Well, hello, everybody. It's great to be here. And I'm going to talk about... That does not work.
1 minute.
It does not work. I'm going to talk about the AI's impact on user interface and experience. And I was hoping for this to be an interactive session, but it's very bright up here. So that'll be more of me speaking. And anybody that's excited about talking, please raise your hand. Somebody will bring you a microphone, okay? So basically, impact is understanding the needs, understanding the tools, building things, and testing them. Without testing things, many people just design with waterfall and they don't get anywhere. AI is representation, reasoning, and learning. So it has been what we've been talking about for 80 years, and I'll say a few words about what AI is as we go along. User interface is taking the tool out of the task. There are many ways to have a user interface, and I'll talk a little bit about that too. But first, I might as well say something about myself, which is I've been teaching at major universities for a lot of my life, but not just teaching. Always I am building things. And so my research group at IBM Research, it was about user interface. And we started very early thinking about user interface, including physical, graphical, and cognitive interface. So cognitive interface is what we talk about when we talk about AI interfaces, such as ChatGPT. And also, now I am spending more of my time doing things like what I'm doing with L&T, which is helping build a generative AI-based chatbot. This is our knowledgeable AI. So just a little bit of history about AI, which was the first word in the name of the title. And really, it started a long time ago. So there's a man named Hebb, and Hebb started thinking about how to model a neuron and how neurons would work together in 1947. And then in 1956, there was a special summer, and several people got together. These people that you have the picture of over here, they got together, and they talked about it. And this man, John McCarthy, he named it artificial intelligence. He didn't want to talk about it being machine intelligence because he wanted people to think about people. People are always important. And so then there was the first demonstrated Turing Award winner, and that is ELIZA. In 1965, there was actually a demonstration of an AI system that confused people, and maybe they thought it was a person. Why did they do that? Well, there were other AI systems modeling psychological things. ELIZA used a Rogerian approach, and it says, and you say something to it, and it says, well, tell me more about your family. Tell me about your mother. How does that make you feel? It had some very simple things, but they're all soliciting some social response from people. And it's that social response from people that made it so exciting. Perry was another AI system that was modeling psychological things. It had 2,000 rules, 1965, 2,000 rule system to model schizophrenia. Nobody wanted to talk to this thing, okay? In fact, so we don't remember it very much. But ELIZA, I will point the star here, is the beginning of what really is the important thing that generative AI brought. So after that, we have Seymour Papert and Marvin Minsky. Here's Marvin Minsky. They wrote a book saying that neural nets cannot do anything. And they said that because the computers were so slow that they could only go one layer. And with one layer, there's not enough connectivity to actually make all of the connections. Now, of course, we have very, very deep neural networks, and they make a big difference. Of course, then we also had a lot of people in the 70s trying to work with representation and reasoning. And what they did is they made things that tried to model something like, Schenck, he was about recognizing newspaper articles, and Winograd, well, he was about prepositions and whether things are on top of each other, and Bobrow was about general reasoning. And so these guys were really important, but their approaches were naive. Well, maybe they just were what we could do at the time. So this guy basically said, well, let's do a moonshot. And so we got lots of money from the government for the fifth generation project. And the problem with that is that it got everybody so unhappy with the fact that these these AI systems were brittle and maybe had the wrong answer, maybe we see that still, that there was something called the AI winter. And in 1983, a very bright man, but he said, you know, this is not working. He shut down all funding. So for about 10 years, we had nobody doing a lot of big funding for AI we call it the AI winter. Now, luckily, IBM continued to do research, and what this guy Fred Jelinek taught us is that he could make text recognition systems better, not by using grammars and syntax the way that we had learned in our computer science department that type 1, type 2, type 3 grammars, but rather by statistics. So this is the very first big success. And this, what he says is every time I fire a linguist and hire a statistician, my system gets better. So this was all the way in 1984. Google in 1998 started hooking things together, making the representation of the world and using that to reason about what the searches would come from. So that was a different kind, not the kind of AI we use today. That's still back with just hooking things together. But what they did is by testing all of these links and watching people train the system by the links that they made, that's the way it learned. It learned by watching people's linkage between things. Now, the next thing that happened was that Deep Blue and Jeopardy won these, Deep Blue, it won the chess tournament, and Jeopardy, it could outperform human in answering questions. This was old AI. These guys, just gigantic amount of data, push it into the computer. So really, that is not a big, but we then, the representation matters was important, and knowledge matters. I say Siri and Alexa, these were not using LLMs. These were hand-built chatbots, really, about everything they could think of. Big companies with big efforts to make them. The real breakthroughs came with the LLMs and the machine learning at Google in 2011. There's a couple of papers that came out. Everybody started understanding that we can use tensors. That is a vector that goes through all of the data and says that anything that's related to anything else is reachable when we're talking about that thing. And that really was the beginning of the modern era. So in 2011, we start having this, and basically, we used LLMs for many things. Google used it for everything. But in fact, right before ChatGPT came out, they tested writers. Can writers write better using LLMs? And the writers had user interface to poke at different things, improve my this, improve that, and they don't want to touch it. But the chatbot, this is a very different thing. When we get generative AI, we have a social model. Like Eliza, all of a sudden, we are telling the computer how we want it said, what voice we want it. It has an idea of what is persuasive. It has an idea of what a paragraph is. It has an idea of what a list is. It has an idea of a conclusion. Those actually, what's funny about those is those aren't using the deep learning. Those are just modeled based on what we know about conversation. And I say that the most important thing is a model of social response. And I would also say that when you make anything that does not have, that is not socially appropriate, people will not use it. And so we have to really think when we're building everything, how do we make sure we are not breaking the social contract with people? I'll talk a little bit more about that. So, of course, impact, well, that's going to be about innovation, entrepreneurship, but I will just move on. The impact, I'm proud of this, I guess. Yeah, so impact is when people notice you, right? They noticed me, put me in the Wall Street Journal, then I feel good. So what is impact? Impact is if this conference if somebody writes it up, if this chatbot that we are building, that we're going to deploy, today if people start using it. And that's really what matters. So what is user interface? User interface is using any kind of sensors, text, graphical, physical input, to find out about a person. Here's actually an oven mitt. The oven mitt, where it is sitting underneath a pot, holding something in the oven. That is the input to the user interface, and it talks. It tells you, ready to take out, burning, it says all sorts of things. But graphical interfaces are like my adaptive help system that was in OS2. I built this one, and see, I'm using overlays to make people focus their attention on this graphical user interface. So it's a multi-layered interface. We have something that you can do with a cursor, and then there's something it's trying to tell you, and then it has different ways of telling you, but it's graphical. And we have this was a system I actually did with DeBragg, where we were using visualization to help people make cell phone towers work better. But also, interface can be as stupid as a switch. I made an RFID card where you have to squeeze it to make it work. This is user interface also. And if you don't squeeze it, then nobody can steal your RFID card. Anyway, I often talk about this example of TrackPoint, which is that we used AI modeling. And the AI modeling, what it knows about is it knows how fast your eye can move. Smooth pursuit. It knows if your eye's going faster, ballistic. It knows that your finger is shaking. And built into this little sensor is an AI model with representation of the cognitive problems underneath the issues of making a pointing device happen. And so it was 20% faster. In fact, let me see if this can play. I don't know that it will because of some problem. No, the audio doesn't work. I'm so sorry. So the point is that when you're making a user interface, you have to understand psychology. And I'm going to come back to this cognitive, this is back to the social thing, but it's even deeper. Perceptually, we have to recognize that the tremor control in that pointing device and watching the eye move at a certain speed, smooth pursuit, those made 20% improvement in how fast you can make a selection. Ergonomic, you have to make something that's reachable. That pointing device, by being in the middle of the keyboard, you can save almost 1 second every time you're about to reach for it, instead of a trackpad. Precognitive, it turns out that there's some things that you can recognize even before your brain turns on. For example, shadows, and if something's convex. These things can be used in user interfaces to make them better. And cognitive, you know, if you make people have to remember more than 7 things, they can't remember them. And so we have to think about that when we're designing user interfaces. And behavioral, we have to think about what is a person able to do? What do they do? How do they act with another person? It's really strange when everybody is now falling off of the Taj Mahal while they're trying to take a selfie. In our country, actually, because we aren't thinking about behavioral issues when we're thinking about designing our user interfaces for telephones, more people are now dying by texting than by drinking. We used to have big problem with drinking and driving. No. Now it's computers and driving. Anyway, social. We have to understand, what is this user interface doing? Is it coaching? Is it mentoring? Is it coaxing? Is it at least listening? Anyway, so we have to really understand how to make conceptual models of learning to be able to make good user interface. And I've made so many user interfaces to demonstrate this idea of making considerate interfaces. Considerate interface is one that's going to be recognizing your relationship to it. That's the #1 primary thing. For example, I wrote a book on peripheral interaction. Peripheral interaction is that for the last 80 years, computer thinks you're the only thing talking to it. But actually, there's many things going on, and you are not paying attention to other people, then you will make them angry. So we have to make our user interfaces, especially with these phones being used in social dynamics all the time, and in physically dangerous places, we have to make it so that you are paying attention to the people around you, the physical surroundings. This is what peripheral interaction is. In any case, I've made smart interfaces with AI in them that you wear as a helmet, that you drive as a car, that you wear as a pair of glasses. This one is for email. I'll talk a little bit about some of them. So basically, one of the first things that I did is I made an AI system that would actually help people learn much better. And what was exciting to me was that the short number of rules and some understanding of how to teach made this thing give people the ability to get 5 times more exercises completed when they were working, when they were trying to learn a language, than the same interface with the same help information, not using AI to present it. And today, we can use AI in ambient situations. In an environment, the interface can know what's in a shop. That's a system model. It can know what you have at home. That's a user model. It can know what you like. That's a user model. It can know what you want others to think about you. That's also a user model. And it can know how you react to suggestions. That is learning. So a lot of times when we make these AI systems, we have to recognize some learning is helpful, but you don't want to do so much learning that you are unstable. It's very easy to change what is going on in an interface too much for a person to understand what you've changed. And I won't get into that more right now, but you can ask me about it later. Anyway, there's somebody standing in a showroom, and the AI knows what's on the clothes rack. It knows what she owns at home. It's showing her near her office. So it's thinking about all of these things together, combining them to one approach. So I'm not going to say more about this, but I'm just going to say that what I've been trying to bring up is that intention can be recognized and respected. Systems act in social situations, and we have to make our systems that will support our goals using social feedback in all interactions, using sensors and virtual sensors. Virtual sensors are the models that we build that are built on the things that we know. So that is what virtual sensors are. And if we don't think about the scenario, how will the person and the system work together, the person and the other person even, we will not make something that it works well. Now, here's an example where I just put one photodiode looking at my eye. And what happens is when I stare at this dog, if I stare too long, it starts barking. If I stare at another person, they get my business card. If I blink nervously, it knows that I am not interested in something. If I wink, it knows I'm trying to flirt. So just with one photodiode, not a camera, and one little teeny computer, I could tell so many things about a human intention. And this is what we want to do with modeling. We want to say a little bit of sensor and a lot of modeling makes understanding. That's me on Good Morning America, actually. Oh, we don't want to talk about that anymore. So another example is this robot seeks work as fuel take inspector. And what happened was I was just looking at the screen, and it could tell I wasn't doing anything, so it gave me some news. So this thing called interest tracker, it simply watches where my eyes are on the screen, and then decides what I'm interested in, and helps me get information. While we were building this, actually, it brought up some information about from the compiler and help system that the person writing the program was able to use. So tracking a person's interest while they're staring at a screen might be a very powerful scenario for improving interfaces. In fact, we also made another system where we had all of the sponsors of the Media Lab. And this person with that eye tracker, he's watching that people grouped the banks together, and then it puts them all together on the screen. And so if you look at this picture here, this one here is the way eyes move when you're asking about the material circumstances of the family. And this one here is the way it asks when you're asking who's in charge in the family. So the eye moves very differently on the screen when you're thinking a different thought. And in fact, what's surprising is that this is the movements of a mouse. And we found out that moving the mouse, you can get 2/3 of the information you can get from eye tracker. So the eye tracker is much better now than it ever was because we have cameras on all our computers, we could use it. But even just watching a person's movement with their mouse, you can tell a lot about what they're thinking. Now, I made a car coach. In this car coach, I found out that when a person's driving, they are not driving their best always. But when we gave them criticism for making mistakes, they drove worse. So when we gave affirmations, smooth acceleration, good braking, thank you for putting on your blinkers, then they drove better. So it's very interesting that we can actually make people drive their best by saying nice things to them. But we didn't know beforehand that it was important not to criticize them. So even before you do, you have to do evaluation. Because before we were showing it to the press, and they loved it, and when the person drives away from the curb, and they said, blinkers please, because they forgot to put on the blinkers, they laugh and they put them on. And we think we succeeded. But when we run driving in a neighborhood, then we find out negative feedback, they start making more errors. So you shouldn't criticize your wife when she's driving. And so I guess I also have made AI using cameras in many places. This is a vending machine where when you, I think I can, yeah. That when you walk up to it, it recognizes there's one person or two people. And if there's two people, it makes a game for them to play together. And if it's one person, it just turns into a vending machine. And then it makes a big celebration when you get some soda. But anyway, the point is that face recognition is to the point where you can actually watch how people are, who is there, and also what their reactions are just with their faces, and make interfaces that way. But the point I've been talking about is basically when we're communicating like these two people, it is always about their posture, their gestures, their distance between them, their hand gestures. We will use this. Interfaces will use this. And really the point is that we have to understand the intentional stance and the social actions, or we will not make a rational agent. So we want to reduce cognitive load for working with things by saying things that are pertinent and valuable, thoughtful and caring, and receptive and reciprocal. Not distracting and disruptive, not condescending. You know, easy on the gas, that's one of the things that car used to say, or condescending or hostile or manipulative. You've made an error, you know, try again. All of these things that we often put into our user interfaces. So appropriate social feedback using AI models in situated social contexts is really critical. So AI can be considerate when I'm thinking, talking or doing. Timing is important. How? Social rules of engagement are important. Affirmation and listening. What? Peripheral things. Be aware, be ready to explain, to expect that the person is not just only paying attention to this user interface. And why? Because I can add agency and continuity to the person's experience. And so here's something I'll talk a little bit about later also, but this is an interesting one where we color-coded the emails. And it's kind of an ugly interface. I mean, it's got these different size fonts, and it's got these bars on it, and it's got these different colors. But actually, instead of a plain interface, people chose to respond better and faster to the emails they should when we pointed out that some of these things were urgent, some of them things were not so urgent, and some of them didn't matter at all. And so by watching the social dynamics in the text that was describing and the relationships between the people that were being talked about in the emails, we were able to give them a color code, and they answered more of the emails that they should, and had a more, and actually were more productive in our experiments. This one, this is actually based on a paper that got best paper award, and later on lasting impact, because it created the field of semantic analysis, sentiment analysis. And this guy is very excited because I said I went skydiving last Saturday outside New York. So it says surprised, happy, sad, and by making those faces, it's reacting to the person typing, so you can get a feedback. Because normally when you're talking to somebody, you're getting feedback all the time. What are they thinking? Why am I succeeding in my communication? But when you're typing an email, you don't know. And so we end up, starting in the 1960s, people talked about flaming. Flaming is when you get too excited with your email, or maybe with your social media, and maybe the whole world's got problems because people are getting too dramatic because they don't understand how their stuff's going to be received. So when you're making a model, you have to, let's see, how are we doing? You have to think about many things, and you can try just making training data and using ensemble learning. This here is a model actually that has 25 different tones. So it's got sexist and racist and ageist and confident and apologizing and deferential, all of these different ways that a person can be responding to another person. And what we found is that when we started off with this thing, first we tried to use other people's models, but their models weren't good enough. So hugging face was not good enough for us. Then we tried to use one-shot learning, just a couple of examples, but actually those are only they're 60% right. And being 40% wrong is pretty awful. So then we started using ensemble learning, where we actually had different systems that learn about all these 25 things, but then getting all of these LLMs to coordinate. First of all, the response time goes shh, computation goes shh, and there's none of the interactions within it. In the end, what we find is that when you're doing fine-tuning with these LLMs, you can do better by putting all of the data in that you would normally used to put in ensemble learning, and actually let the system absorb it and use that beautiful transformer architecture and those tensors to weed it out. We got 90% efficiency with this thing. This is 106,000 cells actually. So there's you have to have 250 examples of things you're trying to train an LLM to be successful. But anyway, in the past we used to have voting between these different smart systems. By the way, Google still does that. They have 3,000 different intelligent agents inside of a search. And whenever you push the button, those 3,000 things are all deciding who gets to answer the question. So that's computationally very expensive. They're a rich company, they get away with it. But now with these integrated solutions, we are starting to be able to do better with our AI than that. So the question of whether we can use AI to help people communicate with other people, that becomes more exciting than just people interacting with computers. And in this case, I'll just talk a little bit about this, here, this is three people talking, and one person is dominant. 100% of the talking is happening by this green person. And then we just said, turn taking, and they went down to only 40%, and we said to this person that wasn't talking, something to say, and they went up to 40%. So an AI agent said these things, and it changed the dynamic for minutes. It just kept, they actually followed the direction. So that was exciting. We also found that if we had a person say, could you mute your microphone? Everybody's stress goes up and they make more errors in their communication. But if we have the computer say it, it says noisy, Then it does not. And so you'll see that the errors were 1/2 as many errors in communication when the computer said we have to change the microphone than when a person did. So I did many things to try to understand what is going on in social dynamics of a conference call, and finally wrote some papers about this, and made a system that actually uses that can reduce people's difficulties in communicating. So when we're trying to have impact, we have to understand that everything we do has to have function, aesthetics, and evaluation. Function is how it works, and in this case, we've got these drivers, and there's kind of are they playing a game out there on the street, or is it a competition, or is it a culture? Actually, these drivers in this part of the world, they're something that they're like Olympic athletes, and so they're finding the flow, and they're finding a path, adjusting their tactics, getting ready with gassing up when they have a chance, and signaling, well, they're honking their horn all the time. But the aesthetics are that they brand themselves with colors and materials and look, and they're dancing. Somehow, even this process of driving, they're showing each other and showing the people they're driving that they're special. The evaluation is, you better not bang into things, get there in a reasonable amount of time, and respect the passengers. So whatever we're thinking about, what I say is that engineers, they think too much about the function. The marketing people, they think too much about the marketing and sales, think about too much about the aesthetics, and almost nobody thinks hard about evaluation. Maybe you find out this sheet at the end of the year whether your company succeeded, but I think you have to integrate all of these much, much more than people have been doing. So everything can be improved. Here I am supporting the scientific expedition to Everest, and they had put the blood oximeter on the finger of the mountain climbers. It's kind of weird. I mean, how can you put it on a glove? How can you grab anything if you have this blood oximeter on your finger? So I put it on the sternum. And, you know, everybody was going to give up, and the climbers were not going to use this. But then I just experiment. And you have to experiment, and there's always ways to solve problems. And we have what we need, usually much more than we think. So I have this belief that if you take a look at an action movie is somebody's grabbing, they're on a vine, and then the vine breaks, so they grab a branch, but then there's a snake on the branch, so then they jump into the river, but the river's going over a waterfall, so they climb up on the rocks. So they're solving problems at the speed of physics, right? That's what an action movie is like. And I say that that invention is having ideas at the speed of conversation. And the ideas is more important than idea. So the big man in the room will always say, I got this idea. And then everybody else is quiet. But it's very important for this person, whoever it is that said the first idea, to say, does anybody else have some improvements to this? Does anybody else have a similar idea? Does anybody else have a different way of solving this? Does anybody else have a different problem that we should be solving? And unless we do those things, we will not have enough conversation to have ideas that compete with each other. Because if we have people competing with each other, then whoever's wearing the nicest suit, whatever, might win. But if we have the ideas competing with each other, then we start learning more about the problem and do a better job. So this is, I'm getting to my impact side of the talk here. And so there's this idea that you start with Wizard of Oz. Wizard of Oz is you pretend it works, and then you imagine it and you make skits to show how it might work, and then you gradually replace those props with maybe some code, maybe some user interface, whatever. But you really always want to be testing whatever you build, whatever you try, against the best of breed. Find the one other people have made that's really better than you thought before, and make sure that your system, your chatbot, for example, in our case, is better than that, or at least it does the same things. And so even when you're done and you make this beautiful product, still we need those those people to make those beautiful graphics and explain what it's for, because just finding a chatbot at the bottom of a screen, you will never find it unless somebody tells you to look there. So you should always think about what you can do and how you do it, and experiment. So when you're experimenting, what is an experiment? Well, you can simulate it in your mind, but then you can try this Wizard of Oz thing, where even if you have to show somebody the user experience, you make it in Figma, and then it pretends to work. Or you sit with your keyboard and you pretend to be the chatbot. This is Wizard of Oz, when you're demonstrating what the computer will do without it being able to. But then after you make a prototype, too few of us try it out on ourselves first. We have to pretend we're naive when we're trying out our product, our user interface, whatever we're making. But then we want to try it out on our friend. But we don't want to say we made it. We want to say, hey, somebody made this, not I made this. Because when you say I made this, then they are saying, oh, if I don't like it, I don't love you. That's a very dangerous thing. It's very easy to bias experiments. And then you have to try it out on a group. And the worst thing about trying out something on a group is that if you have the group in a room together, they all look at each other, and one person has one opinion, everybody will have that opinion. That's what that's the literature on focus groups says this. So you have to figure out how to keep the group from being groupthink. And there's something called deliberative democracy that's a good way of doing this. But anyway, my experience, all of the things I make, I test them quantitatively. Is it faster? Is it better? Can people do something that they couldn't do before by using this? That is really important. But actually, the right answer is that there's this chatbot we're going to release today that's going to have AI in it. And how does it work in the wild? The wild, user interface wild, is everybody uses it, and you see how it works. It's very important to instrument things, see if they're succeeding in using it. So, is it recognizable? Does somebody know what it is? Is it desirable? Do they know why they would use it? Does it have a new function, something they couldn't do before? Is it faster? Is it easier to learn? Is it cheaper? You have to think about your KPIs, the reasons that a person would use this. And so really what's interesting about managing for innovation is that 25% of innovations goals come from innovators and 75% from marketing pull. But the thing is that if you're stressed, you don't innovate. So you have to relax. And you see your people go out to get a coffee, go out for a walk, get some exercise. That's when you loosen up. You have to take the time to do it. This is a bunch of computers that I made specifically to use on Mount Everest that had special everything. It was a lot of fun. So the point is that to have success with the things that we make, we have to evaluate the people. We have to evaluate the ideas. We have to put in some money, and then we have to see what is non-competitive, what is the bad size or timing, and what is bad team market fit. So that's success. But really what I wanted to say today, and you're going to hear a little bit more from me maybe if you come to the talk this afternoon, is that AI is broadening our experiences. And I wrote a blog that you can see at ACM, where I say the most important thing is not to get an answer from ChatGPT, but ask it questions that make you think about all different ideas. Just like I was saying, when we're having ideas, we have to have ideas. You can ask ChatGPT or Gemini, you can say, think about it from this point of view, think about it from that point of view, think about a different question, and you'll get different answers. And if you have these answers coming back by very quickly, very easily asking these questions, it is the magic book. It has everything that anyone's ever said. So when you ask it a question, how would people talk about this? How would they say that? It will give a better answer than anybody could. But I think instead of saying, oh, we want to just replace people, I think what we want to do is use it to be teaching us and helping us do a much better job at everything we do. And so with that, I'll just open it up for questions. Can the microphone?
Can you say anything on HMIs?
Joy.
HMI.
HMI?
Yeah.
Human-machine interaction? That's what I work on, yeah.
Anything on that? You have any material to say on that?
What areas?
Yeah, on
Yeah, you saw,
HMI.
I work on every area. I work on physical interface, graphical interface, cognitive interface, yes.
Yeah, because there are certain helmets which come with built-in
Eye tracking, yeah.
Eye tracking.
Yeah. So I'm always thinking, what is a new sensor? For example, I found a way of noticing when a person's driving, are they stressed? We tried 13 different biometrics, and we found one that in 3 seconds I can tell that you're stressed, and stop the stress in driving and you will not have the accident. So there's, the really hard thing when you're designing anything is to figure out what actually is needed to understand this thing, whatever it is. And in this case, I had to discover that by trying 13 different ways. So this is often, sometimes it's the sensor, sometimes it's the AI, sometimes it's how you present it to the person.
Thank you. Thanks.
But even more important than HMI is HH, human-human interaction. And one of my examples is that we can improve human-human interaction by putting AI in the middle of the interaction. And that gets really interesting.
Great. Ladies and gentlemen, please give a big round of applause to Professor Selker for sharing this fascinating session with us. Thank you, Professor. Thank you.